Yep. So is everyone comfortable with English or Hindi? Anything is fine. English. Okay, perfect. So today we're gonna look at a topic called Async PHP. I got the idea about this topic when last time Jigar and me were actually doing a live stream on YouTube about reverb, Laravel reverb, right? So at that time we looked at that Laravel reverb is actually created using React PHP, something called as React PHP, and I was like kind of excited to go dive deeper into that, how exactly that works, right? Because I never heard that you can actually build a WebSocket server or any HTTP server with using PHP, right? Then I was kind of excited to go into much deeper into the Async PHP, and then I found out a very good things which I really wanted to share with you guys today. So that's the topic of my PHP. But before we start, right, I just wanted to ask everyone, who do you like? What do you guys think about PHP? Like in general, do you think it is a slow language or is it's a normal language? What do you think about it?
Not much slower, but yeah, compared to the other languages, yeah, it's slow. I
Slow
can.
in what sense?
Slow in execution speed, the performance wise.
No, getting it.
Okay, what do you think?
It is slow. Slow.
Slow?
Yeah.
Slow? But at the end of the talk, you can actually make your PHP fast by doing some things, right? So to understand why do we need async PHP, right? We have to understand what exactly the problem it's solving. What exactly is the bottleneck with current PHP only. So let's see what is the current state of our PHP. So PHP was mainly a scripting language created to run on the website, right? What happened was later it got added some more features and more features, and now it's kind of a modern language only, like all the modern features are there now, but still many people are using the way traditionally it was being used as a PHP. So how exactly it works? You have a server, HTTP server kind of Nginx or Apache set up in between. You get the request from the user, client, anything into that server. Then that server send that request to your PHP FPM. PHP FPM, I guess everyone knows what PHP FPM is. It's a fast CGI process manager. And what exactly it does is PHP doesn't know what exactly the HTTP request look like, right? So PHP uses this fast CGI protocol behind the scenes to convert the HTTP request into the PHP understandable program. So, and that PHP FPM do that just to have a like a layer on top of your PHP. So PHP FPM actually converts your HTTP request to the fast CGI request and then pass to the PHP processes. That's basically how current PHP works. Like if you know, you get a HTTP request from the client, HTTP server handle that request, Nginx or Apache, and then that request actually passed to the PHP FPM, and then PHP FPM execute that request, send the request response back to the HTTP server, and that response is being sent to the client. So let's see if PHP FPM execution. So let's suppose you have a server, right? You have a PHP FPM running, and you have to in the config you have to tell that how many processes you have to run, how many child process, and all that kind of stuff. By default, if you are using whatever the process you can run, it depends on based on the CPU or the server capacity you are using. So let's suppose you have two cores, and core is nothing but like they are gonna process your request, like it's a CPU unit. So whenever you get one request, it assigned to one core. PHP FPM also do this async way. So if you have 3 or 4 process, the first request will go to one core one. Let's suppose there is a request 2, then that will go to core 2. Same for request 3. And then this HTTP request, right? That is being passed to PHP FPM, and PHP FPM is assigning where I need to handle that. So there is a big request, and now if there is new request coming up, that will go to core 1 and core 2. So you understand this, like how currently PHP FPM works. Now what do you think, what will be the limitation with this approach right now? I will tell you. So whenever request 1 happens, right, entire thing is actually loaded into the memory, like starting from PHP, right? It's a fire and forget model. So PHP works on something called as fire and forget model. So every single time this request comes up to the server, it will load everything. PHP, if you are using any specific framework, that is also loaded. And on top of that, what is your business logic you have written, right? That will be also loaded. and then at the time of executing, that entire thing will be destroyed. So you see all these things, you are unnecessarily loading PHP and all. PHP, if you are using Laravel framework, then Laravel is also being loaded, then your business logic, and you see there's a bottleneck happening. The second big concern with the PHP FPM is, if you are using PHP FPM, you cannot access the network layer thing. What I mean by network layer thing is, you cannot access Docker, DNS level things, right? So those are only accessible in the PHP CLI. So these are kind of the PHP FPM Dockers. You cannot run it forever. As you know, it's a fire and forget model, right? So every request is handled, loaded everything, and just forget, destroyed everything. So you cannot run PHP for a longer time, right? If you want to run PHP longer time, there is kind of no concept of garbage collector. There is, but you don't get to control it, right? That's one thing. So that's also one thing. So you have to don't know how many memory leaks will happen and everything. If you just started a while loop and just keep it running forever, right? You don't know how many memory loop will happen, or how many memory. What is this called? Yeah, basically it's just adding a memory leak into your server, right? Then there is, you cannot actually build with PHP-FM WebSocket, Web Transport, or SSE server, because they have to persist connection between for longer time. So if you want to set up a connection with a PHP-FPM, it has to set up that WebSocket connection for a longer period of time. You cannot just like tell that, oh, the one WebSocket request is handled, now I can close the connection. That is also something which is not possible. Then I already told you don't have access to network layer in the PHP-FPM.
I didn't get this one. No access to network layer. Can you give me some example?
So for example, with PHP-FM, you cannot access the network layer thing. Network layer thing means whatever the HTTP server you have, right? You cannot access the network. So let's suppose if you want to control the DNS layer thing, like if you want to create a TCP streams directly, right? The HTTP, you cannot do that in PHP-FPM. The TCP connections or UDP connections, you cannot do that with PHP-FPM. You can do that with PHP CLI, but not with the FPM. And that's how mostly, I guess, 99% of us are running the PHP in the production with PHP FPM. So, and there is like high startup overhead for each request. You already saw that we have to load PHP and everything. So now we will see how much we can optimize that one request we saw in the previous slide, right? So this is one HTTP request, okay? We do, in that one HTTP request, we first load Laravel and PHP. We have our processing of business logic, whatever it is. Like let's say you have to get some data from database, send emails or something like that. You do that, and then you send back the response, right? And you see every single time this request happens, this is the part which is gonna be common for everything. Like it will always load Laravel, PHP, whatever the framework you are loading. For every request, it's being loaded. You can cache that using OP cache, but that's not actually, that's still being loaded as a value, right? So you are not keeping that somewhere in the memory. So to solve this problem, there are now new frameworks which actually use a concept called worker. Okay,
Service worker.
kind of workers, what PHP FPM use behind the scenes as a workers, right? So they kind of extrapolate those logic into their own runtime. So now because of this, these are the service which are like, these are the new platform which has occurred. So in Laravel, if you know about Octane, right, it does the similar thing. It keeps your application in memory, the bootstrapping logic, the Laravel logic, and only handles the business part of it. Same goes for, and Laravel Octane use OpenSul, Franken PHP, and the Roadrunner behind the scene. So these are also have their own worker mode. So if you are running not running the Laravel framework, right, you can actually use their respective worker mode as well. So Franken PHP has Symfony, all these frameworks, right? Same OpenSul also, and Roadrunner has this frameworks where you can keep the application in memory and only serves the business logic, right? That's happening, right? OpenSul also has this now. Franken PHP is the new guy, and the Roadrunner was there also. They do something, so they keep this entire thing into a memory, the Laravel loading part, and then they spawn up new worker. Okay, so whenever you start Laravel Octane server, right, you see that it is being handled by the worker. You have to mention that in a production and how many workers I need to use, and that's actually gonna whenever you have to execute the business logic, those worker will execute that business logic, send it back to the framework, and then framework will respond back. So entire the part of booting and the destroying the framework logic is actually loaded on the Laravel Octane side. So you get by this, if we are handling thousands of requests daily, right? How much time you can save? Even if frameworks is taking milliseconds to load on your very high side, if you are handling millions of requests every single day, you can almost save few hours, right? In just processing time, unnecessary resource usage, and everything. And whenever you go on the async mode, you have to be very much careful about how exactly you are coding, because if you are not careful enough, right, you will end up writing a bad code, and because of that bad code, right, memory leaks will happen into your system. Your application will use more memory than usual. So, for example, in normal traditional PHP, it's a fire and forget model. Even if you write a very bad shitty code, at the end of the day, it's gonna execute. It's just gonna destroy everything. It's not gonna keep that in memory. But in Laravel Octane, if you write that a shitty code, it will store in the memory. If there is like some variable you didn't like, let's suppose you decide to put a dependency into container which is resolved always, right? That's something which is again memory overhead, and that will resolve every single time. For every single instance will create a new, and so every single time you add any container dependency, you have to get a singleton in this. So you have to be careful about when you are working with this stuff. So that's one drawback, and that's make little bit our programming paradigm little bit difficult. So that's one thing. Now we see we can optimize that loading of Laravel and PHP into separate. Now we see how much optimization we can do for the rest of the stuff. So there is this request which has been come now. Now we are looking at the business logic part. We have optimized the first part. Now let's look at the business logic part. So in business logic, I have to fetch data from API. Let's suppose there is one API to get a post, and then from that post API get all post. I need to fetch every single post detail, and I need to store it in database or something like that. So I need to call 10 different APIs. I need to process some data. I need to store that data in DB, and then I need to update the cache, and I need to send an email. Okay, this is a normal business logic. Okay, and the things I don't know if you guys can see, but these are the things I have marked a little bit gray, and these are like a very much gray. So looking at this, you can see, right, to handle this business logic, we can do these two things asynchronously, right? Because we don't want to wait for sending email. We can just tell the user that we have stored the data in DB, and we will process the we will update the API which we wanted to, and we will update the cache and sending the email in a async part. How we can do that? Very easy. Laravel queues. If you know, we can use queue. That's a very simple way of async PHP. We are running PHP program in a async manner, which is going to execute in some like not in your entire request lifecycle, but in a different way, right? So that's how it's also one of a async way, right? So if you are using Laravel queue, you are using async PHP. So that's also, so you can actually remove these two things into the queue worker, and you can get done with it, and you will have a very nice optimization of the business logic also. So now let's see. Now let's see. This is the basically you do queue and then you update the API cache and send email. Now let's see how we can optimize this part. Right? We have optimized most of the part of a business logic into a queue. Now let's see how we can optimize this part much more. So now I'm going to take the fetching data from API, processing data, and store data. So out of this, you see fetching data from API and store data, it's kind of a IO heavy thing. What I mean by IO heavy mean input output heavy. So you have to set up connection, HTTP connection with the database server, not HTTP, but whatever the connection with database server. With API server also fetching data from different APIs is also IO heavy. You have to set up a connection, get data, and wherever you are processing data, that's a CPU heavy, because that's gonna affect your memory, CPU uses, you are transforming array, you are updating something. So that's a CPU heavy thing. So now both of these things, right? You see, we are waiting for something. Like let's suppose we want to get up all post of that API, and that's taking 2 seconds long. So we are unnecessary waiting for that 2 seconds. Like in normal PHP, if you get HTTP colon gate in a Laravel framework, right? you are waiting for 2 seconds that the code is not going to execute. You're going to wait for 2 seconds, and after the response comes, then you can actually process the data, right? So in order to make this, you understand this. There is a CPU heavy and this is a IO heavy thing. So now we will talk about the normal async stuff, like which happens at the language level. We have done framework layer, then we look at business logic layer. Now we are looking at how we can optimize the code at a PHP layer. So there are three ways to do this. One is multiprocessing. So multiprocessing is what you create another process of PHP from your program that I want to execute this PHP code. Give me the result once you executed it, and that will give you the code. It's a process. So you're gonna start new process. In PHP, there is a plugin called PCNTL. I'm not sure if you heard it. That's used to manage the process, underlying process. So you can just call a PCNTL fork, and that will give you the process. So it's a layer on top of working with the processes. So that's how multiprocessing works. So whatever the problem with multiprocessing is, it's a very heavy to start a new process. So whenever you start a new process, it's a very heavy job. You understand, like you are telling operating system to start new process. Now that operating system will start new process, allocate resource to it, then execute your code, then give the result back again. You cannot communicate it between two different processes, so you have to select use streams for that. So this Unix sockets, right? These are the stream setups between two different processes. So you cannot communicate with two different processes unless you set up some extra things. So by default you cannot, but you have to set up streams. Then that's again overhead, and that's again extra code you have to write. And you will be like, why I cannot just do that? So some smart people came up with the idea of called multi-threading. Multi-thread is nothing but in that same program it's gonna run, but it's gonna use a different thread. Okay, so thread is nothing but again it's a CPU. In that CPU there will be processes, and processes will have a different memory thing, but thread lives into the process thing. So there can be, in one process there can be 1, 2, 3, 4, 5, as many threads as possible, right? But the problem with multi-threading is it can communicate with your program at the same time. Now let's suppose there are two threads. You start two threads. Like thread is nothing but the same as queue, and understand it's queue, but you are telling instead of a separate worker to run, it's just thread to run that code. But the problem is now that thread has also access to your program. If you update one variable into your program, and that another program also updated that same variable, there can a problem of race condition. So you have to be very careful when you do multi-threading, and writing multi-threading code is not a very good. And luckily for us, PHP is a single-threaded language. So whenever you start a PHP, there always a single thread. But there are kind of a thread virtualization which PHP can do. They have a plugin called pthread, by which you can actually start the different threads into your single threaded system, and then you can execute that code. Again, there is a nice yes, that's available for CLI, but at the end of the day you can actually use that in your normal web request. Yeah.
Okay,
Yeah, so there's a multi-threading. We are not gonna look at multi-threading because it's very complicated to do. Like if you want to write a multi-threaded code, right? You have to be so much confident. So much confident, and you have to think of so many things, right? You are not updating any other variables and all. Then comes a thing called coroutines and fibers, which is nothing but a fibers. Now, what coroutines does is, they thought using the multi-threading is kind of a very complicated way to program, right? Now, what we can do is we can do that everything in a single threaded. How? Whenever we do this IO operation where we are waiting for some result, right? Let's suppose we are waiting for that API request to complete. We now gonna wait actually for 2 seconds for that call. But what we can do is we can actually wait for in a different, like the same thread, but we can tell the program that whenever that gets completed, just inform me, right? It's a single threaded it's like a single threaded concurrency that will always run in the same thread. But here you can be more confident because you are not doing that in an async way. So your program will always have that layer when to update any variable, right? So you get the benefits of multiprocessing and multi-threading in the coroutines kind of thing. It's a very lightweight thing to spawn up, right? You can just spawn up like fibers like very easily. You don't have to process overhead. You can communicate with fibers, because fiber you cannot communicate, but fiber can actually start and suspend at whenever they want, right? So you can actually have a logical flow in your code that I need to start this, now I will wait for this, so I will suspend this, now I will start execution of other thing. Whenever that get executed, I will suspend it and I will again start an first thing. So that's where you can actually do a, like you can actually write a nice code with a fiber, and fiber has a native support with PHP now. From PHP 8.1, you can use directly a fiber thing, which is great because then you have that API to start and stop things the way you want.
So fiber, is it, when you say it is available in PHP native, is fiber a separate technology, or what is it? Like fiber has PHP created a thing called coroutine or fiber, or it existed even before and PHP has simply integrated?
So it's a concept. Coroutine is a concept. It's a very famous in a Go programming. So Go coroutines is a very famous way how they manage this coroutines, right?
But it's a computer concept, not the programming concept.
Yeah.
It's a programming concept. It's a programming, and it's very used from very long time. It's not a new concept.
It's a programming concept.
Yes, it's a programming concept, and they have just implemented that programming concept, and they called it as a fibers.
Okay. So PHP में उसको fiber बोलते हैं.
Exactly.
I guess Kotlin has coroutines.
Yeah,
With that name.
yeah, coroutine. Exactly. They are doing same thing at the end of the day,
Okay, got it.
but just naming convention wise, they are using fibers.
Okay, PHP calls it fibers.
Yes.
Kotlin calls it coroutine.
Yes.
So, if my understanding is correct, so PHP is written in C. So some PHP developer, like core
Right.
developer, has written a C language to implement this coroutine.
PHP.
Exactly. So they have to write a low level C program in order to, so they will do heavy work for you guys. They will give you such API implementation that you can easily work with the fibers. Behind the scene, it's using C only. But it was not natively available before. You have to do lot many stuff already. But now it's natively available.
So now, if my understanding is correct, this multi-threading and multi-process is at OS level. Is at OS level, but coroutine is at programming level.
Exactly. It's a programming level concept.
Okay.
It's happening at a OS level, kind of program process level. It's operating system level.
Okay.
So we will see the difference between each of it. So multi-process has independent processes. Memory usage is high because it's starting a new process. It will take another space of it. It is slower in because you cannot communicate with different processes. Complexity is moderate because it's easy to work with. You know what to expect. It's like same as queue worker, right? Based for CPU intensive task, because whenever you need to use CPU intensive task only, then you can go for multiprocessing, because then you get to use entire CPU resource of that process, not just that one single program. And then there is a PCNTL PHP support, and that's CLI only. Multi-threaded is parallel. You can share the threads between each other, and its memory usage is low because it's spawning up in the same process. Communication is fast because they live in the same process, and complexity is very high. I told you already, like writing multi-threaded code is one of the hardest thing you can do. And then it's kind of a lightweight parallelism where you have to tell that, oh, just give me this little bit of things. I need to wait for this API response, just execute that and give me that. That is very nice use case for multi-threading, right? And PHP support is there, pthreads and all. Okay, now there is a coroutines.
So when we say parallel programming and multi-threading, both are the same, right?
It's all our parallel programming, paradigm of parallel programming. They are gonna execute your code async way. So now comes to coroutines. Coroutines does something very intelligently. What they do is they start a new processor in your PHP language, right? That tells us that I will execute whatever program PHP code you give me, but I will do that in the same thread. So you don't change the thread logic anywhere. So you have like little bit less complex than the multi-threading stuff, and like very low memory usage because it's happening same in the program. You don't need to start any CPU recess, right? It's happening on the same programming. then communication is not needed because it's the same thread only. You can just start, you tell that this I'm gonna update this variable, and you will get updated a variable at the end of the day. It's a moderate complex because you have to now wait for that stuff to happen. Like, you use yield keyword in PHP. Like whenever you have to do a very high files parsing, right? High, like very big high file parsing, you use yield keyword to unleash wait whenever we are gonna get to that pointer. So you will just keep a pointer to that file reference and then just go till that point you come. You don't store that in memory. So the similar thing kind of happens there.
So generator.
Exactly.
In PHP there is a generator, so it uses fiber behind the scene.
Not, it's not. It's kind of a same paradigm. It not uses fiber. It uses the pointer to file, but it uses a different thing. It's a kind of a same. You have to yield for that. Basically, you have to wait for that process to complete, and because of that, it's less complex. That's why it's a less complex than multi-threading. It's very good for IO inbound task. I told you, right? Sorry.
It won't cause any issue to the main program.
You have to be careful whenever you are writing all this async code. You have to be careful about it. Exactly.
JavaScript में जो promises है, it's the same thing, but JavaScript has their own like queue structure.
Exactly. So I'm coming to that point. How exactly the JavaScript concurrency? JavaScript also single threaded. They also implement a async process. How do they do it? Browser provides them something called as an event loop, right? That event loop is nothing but that tells JavaScript tells that event loop, I need to process this asynchronously. Whenever that executes, just call me, right? And that's the same thing happening in the PHP. So they have implemented kind of a event loop, and we are going to look at the event loop after this one. So you understand coroutines is very good for IO inbound tasks where we don't have to do any processing, but we have to just wait for some time. So we can actually offload those things to the coroutines, and then we can just wait for it. And I already told you PHP Fiber has the support, like native support for the coroutines.
The question on again, what task we can pass with a multiprocessor and with multi-threading?
So let's suppose you
Better example.
yeah, okay. So in multiprocessing, let's suppose have you guys heard of this 1 billion row challenge?
Checking for
Yeah, so basically this one group of developers, they actually came up with challenge where they have this 1 billion rows in a file. Okay, that file is like 13 GB or something, and then you have to find some do some calculation on that file, and you have to process the result at the end of the day. So, and whoever is gonna do that very fast, like at the fastest time, they will win that challenge. Okay, so for those challenge, right, where the competitions are very high, like you are doing crunching a large amount of mathematical data, doing some sort of very crazy array conversions and everything, calculating so many things, right? The multiprocess is very good for that use case. So what you can do is you can chunk that big file into a different chunks. You can give it to one single process and tell that whenever you get complete, I just give me the result, and then you can just. So that's a very good use case for multiprocessing, and that's why I told you this is a CPU intensive task. So whenever you are doing some very heavy task, you always look out for the CPU like multiprocessing. Whenever you are doing very much IO inbound task where you are connecting with database a lot, let's suppose you are connecting with 5 different databases, Redis, everything, or connecting with different APIs, that's where the coroutine works. And most of our Laravel application is IO inbound task. We are connecting with database, we are updating cache, we are getting updating API or something like that, and that's most of the usual stuff we do with PHP. So that's why the coroutines is based for, and we mostly gonna look at for the coroutines because multiprocessing has a very limited use case, but coroutine has kind of a very good possibilities.
So in the current scenario, coroutines has more weightage than multiprocessing.
It depends on your use case.
If you are using like if you are working with Java is multi-threaded.
Yes.
So like the reason it is multi-threaded, hence it is used for like software as
Exactly, CPU intensive task.
Yeah, but PHP is specifically for web.
Exactly. So that's why I told you there is very less use cases for multiprocessing. We use for web storing databases, connecting databases, updating cache, updating like calling some APIs, getting response, processing that. That's what mostly we do, and that's why we can get use of this coroutines. We can understand it easily because there is I don't think you guys are crunching a lot of numbers, big numbers, doing some calculations, doing some sort of things, and then in that case, multiprocessing is a very good parallelogram.
So is coroutine used multi-threaded behind the scene or not?
No, so they use single-threaded concurrency. So they use only one thread, but they kind of use a concept of multi-threaded,
It gives you a virtual thread
kind of a virtual concurrency.
Basically, long running thread.
long running thread. जो
Long running,
basically
then it can do a lot of things.
Exactly. And I will coming to the point. We saw that limitation of PHP FPM. The moment you look at the coroutines, right? You have like now extended the use case a lot. Now you can actually wait in a program because you can tell fibers that I need to wait for, like, let's say, unless the TCP stream is coming, I need to wait for it. Okay, and that time only gets suspended. So you can actually now write connections, HTTP connections. You can now WebSocket connection that wait for time till the clients close the connections, right? You can actually then close the fiber and then PHP execution will stop. And that's why the fiber can actually open lot many opportunities for you to write a code in a async manner. You can mostly overcome with all the limitation of PHP FPM. Now we will see how we can achieve this. So there were previously these three libraries which used to support kind of what we saw the coroutines were. Now it is native, but earlier it was React PHP. There is a thing called AMP PHP, and there is a thing called Spool also. They use both, they use all coroutines behind the scenes. So you can actually have, look at those documentation. We are mostly gonna stick to React PHP because it's most widely used right now at the community. So that's mostly it. It has some concepts which we need to learn, and all has very common concept. Okay, the same we talk about the event loop. Then there is a concept called stream. Then there is a concept called promises, and there is a concept called async. So we all gonna see that in coming slides.
So when you say it's native in PHP, so why we need these libraries?
This is before the fibers comes. They actually implemented that whatever the fiber was implemented. Now you can actually, many of these libraries are using fibers behind the scenes to implement all those concepts.
Oh,
So
okay.
fibers is a very low level concept. So you will see fiber as if you want to write a code with fiber and you go to the documentation of fiber right now, you will see I didn't understand a single thing because you don't know how exactly it is beneficial, right? Because the way fiber works, right, it just gives you the program execution thing, right? I need to start this program execution, I need to stop it, and I need to resume it. You will like what I will do with this. But when you go into much more detail, you will understand there are libraries built on top of it, which actually gives you most use stuff like event loop. Event loop is a very good example of a fiber. But if you want to implement event loop, you have to use fibers behind the scenes right now. Like if you are using PHP 8.1, this library support PHP 7 also. So that's why they implemented their own event loop in the normal PHP.
So before the fiber, those libraries are the only way to implement
Yeah.
fiber.
So
Now they are using fiber behind the scene to work with the PHP.
yes. So this Sool did it differently. They actually created an extension.
Okay.
Sool is an extension, PHP extension. AMP PHP is a library, but they also needed some extension to run that. And React PHP is the only one who actually write it into native PHP and give you that feature. Okay, so that's where the React PHP actually shines. And now there are another library called Reviliate and all, which actually uses PHP fibers implementation to do all these things: promise, HTTP code execution, async, databases connections, and all. So it's a very low level
just a random question. Is it connected to React by anything?
It's not connected with React. There is a very funny thing which I learned when I came across React. So the guy who created React PHP actually created before the React actually came. So they have before 3 years back they have a React PHP, and they actually created a thing called React. Whenever something gets updated, update the entire DOM.
Basically, it reacts over the.
Exactly, and that's what the paradigm before behind the React PHP.
So
So
even I thought like React PHP sounds like a version of React PHP.
so it's actually came into 2011, and the React actually came into 2014. So it's 3 years back they actually got, and now React is much popular. But
I think what you said earlier makes sense because this caters to niche audience like developers who create low level.
Exactly, who creates libraries basically.
For developers like us.
Exactly. Right, like so I will understand. Have you written HTTP library? You use always Gazelle or maybe Laravel HTTP, right?
बेसिक करता डेटाबेस कनेक्ट करने के लिए MySQL के सारे फंक्शंस अवेलेबल है PHP में फिर भी हम वो आ रहे हैं
Exactly. That's why, because we need that experience. Like you cannot always start MySQL connection and everything. You need that, and those people, the library creator actually uses those low level stuff to give you the a very nice API access, right? So if you see Laravel HTTP, right, behind the scenes it uses Gazelle, and Gazelle also uses behind the scenes some React PHP curl, and it also has its own React PHP implementation.
Now I think their call is not dependent on.
Exactly, they now have their own async engine created, same as a React PHP. So now, even though you are using async way, but you don't know you are using it because you are using the very high level stuff of that. Exactly. But we are not today. We are now today gonna look at how exactly the things go at low level to understand why, if there is a need of something like this. Okay, so I'm gonna sit and now I'm gonna write a code, some code, and I'm gonna show you too as well. So before that, we're gonna look at this library called React PHP, right? It's a very old library, battle tested for production. Many libraries use this. So if you have heard a called PHP stand, right? It depends on the React to make it everything fast, and it's a like it's doing most of the file stuff, right? Interacting with file, processing it.
IO files basically.
Exactly.
IO service.
IO file is nothing but a IO. Yeah, I have it right now.
But it's slow.
Okay.
ये UI MPL की तरह ही है.
Kind of, yes. It's a, they are trying to build something called as Node. So Node also has this event loop, but they natively implement it. Browser JavaScript doesn't have something called as event loop. JavaScript run in whatever environment it runs. JavaScript can run in multiple runtimes, right? It can run in browser, it can run in Node, anything, right? So they gives us the event loop capability. So let's see event-driven non-blocking IO with PHP. It's a very simple explanation. It's a low-level library for event-driven programming in PHP. At its core, it's an event loop. Basically, event loop is a very core thing which you have to understand. And what exactly is, we're gonna see that. So React PHP has this core components, 4 components, and then have this network components. Like you can connect with the sockets, HTTP server, DNS resolver. I told you, like, we don't have option to resolve DNS dependency with PHP. We can actually do that with React PHP. With the datagram, we can connect with the UDP connections also. Then there are utility components. Like if you want to work with a cache, like cache is nothing but a memory cache, right? If you want to store something, you can use that cache. Whenever you use Laravel array cache driver, right, that stores the data into memory. So you can actually use this cache driver also. Laravel implements its own array cache. You can actually use this async cache also. And I want to try that. I didn't got a chance, but I'm gonna try that to see how exactly it's different with if you store the cache with Laravel array driver and with React PHP cache driver, right? Then there is a child process also. You can interact with different processes, right? That's also one very good case for a fiber, like because then that program execution can happen in that way, another thread, and you can actually wait until that execution happens. So you also get a very nice layer on top of the program execution. So that's also very good use case for this, and it will set up everything. It will set up stream and everything. So you will get a very ready-made library for working with the different processes. And then there is a promise timer, and there are many things. So we're gonna look at the code now, and I'm gonna go to. So I have created some examples to show how exactly this thing works. So I'm just gonna go to first thing, checkout revision, and this is a basic PHP application I have set up with basic composer and composer JSON dependency. That's it. I am auto loading that here, and so this is the loop thing. Now React PHP gives us the event loop. Okay.
Yeah, better.
Okay, so React PHP gives us this loop thing. Okay, and this is kind of a facade, right? You can actually create a factory, get a factory method to give you the loop. You can create your own loop starting and everything. But if there is a very easy way to, like, kind of, it's a facade pattern, like loop get, you get a loop. Okay, then you add some periodic timer. Periodic timer is nothing but a set interval in JavaScript, right? Whenever you add set interval, wait for this time and execute this code every single time. That's same thing with a add periodic timer. Loop add timer is nothing but a set timeout in JavaScript. Set timeout is like the same thing. It's gonna execute.
You don't wait for the 10 seconds and then it will execute.
But it wait async way. It's not wait. It doesn't block your entire JavaScript execution. It wait async way. It waits 10 minutes and then it's gonna give you. So the same thing happen. You pass the time. You pass the callback function which needs to execute, and then at the end of it, you run it.
So it will keep executing in background.
Exactly. And the moment it doesn't have anything to run, like in that execution mode, it's just gonna stop it because it is gonna run forever because I have a periodic timer. So unless that periodic timer is there. But what I'm doing is let me show you something. I'm just gonna comment this out. I'm gonna run this code. So if I just show you how I'm doing that, I have added a script called dev, which is just running the index file. Okay. So now you see for every single, and it's gonna start executing unless we signal that to stop. Okay. So this is gonna executing because we are not canceling thing, and every after 10 seconds it's adding done also, right? Now moment if I want to stop the execution, if something happens, if some WebSocket connection gets completed, I want to stop the connection, so I can actually stop this event loop. This is very low level stuff, like we are not even seeing, we are seeing very low level stuff by how exactly it works. So I go here, I run it again. Now it gonna execute for 10 times and then it's gonna cancel the timer. Whatever I'm just passing that here and I'm gonna stop that. So after 10 seconds, it stopped automatically. I didn't stop that. So you can actually control the flow. You can now run long running processes and you can wait for the processes to, like, you can wait for the processes to happen. So you now get a how many things you can do with PHP. If you can wait for some time, then once that program is done, you can tell that I'm done. I just need to stop this event loop.
So if I have some other code in between these,
Yeah, that will execute. So let's suppose if we add, okay, and let's suppose if I add sleep here, sleep for let's say 5 seconds. Okay, done 1 and done 2, and I'm just gonna give 5 seconds for now. So now you see tick, 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 done 1. Now wait for 5 seconds and done 2. Whatever the code you write here, you can actually get it. Now the one thing you have to be very careful when you are dealing with this event loop. You cannot start another event loop inside one event loop. If you start it,
I was thinking of the same thing.
so if you do that, it's just gonna make entire thing blow, because the way React event loops work, it's only give one event loop. You can only run one event loop at one time. If you started to do that, right, what will happen is that those both of the execution of those both event loop will coincide with each other, and that will create a problem, lot of problems, right? So sometimes if you are listening for periodic timer 1 second in this loop, and the same loop you are listening for 1 second, the another loop, they will coincide with each other, but the program execution will not happen exactly at 1 second. There will be some gap, right? And that's why we don't want that thing.
So basically, if I have a variable named loop2, which has another loop get,
That
but is it a singleton or
it's a singleton. Loop get is a singleton. It always gonna give you the loop which has been created.
so there won't be any second loop? It will be the same loop itself.
You can actually create a loop manually also. So basically, if you go here, you can actually create another loop in factory. So and on this loop method, we can see there are some methods also.
So
So
we can add multiple add periodic timer, but we cannot add multiple time periodic time inside another one.
another loop, like no, so you cannot use another loop also. Whenever you are using loop, pass that loop everywhere in the program, that pass that loop that I want to execute in dot loop, because what will happen if the two loops started coincide with each other, the program execution won't be completely async, there will be some delay.
But what if I want to process multiple API requests?
You pass it to same loop that will execute it async way.
I'm still not getting the loop concept here.
So loop is something I will tell you. So loop is it's something which is kind of a while loop, okay? But it's while loop is a synchronous. Event loop is a asynchronous way. Okay, you tell that loop to that add a timer. Okay, now that loop is gonna take that. It's gonna start another thread, whatever it is. It has its own way of starting a PHP process. That PHP process will start a timer for 5 seconds, and whenever that 5 seconds works, it will tell that loop that now I am done. Now whatever the response, whatever the callback you are passing, right? Whatever the callback you are passing, the execute that, and whatever the callback we are passing, it's going to execute after exactly at a 5 second, because there is a timer in that same loop. So let's suppose you are adding 10 timers at one loop, they're going to execute at the same time because of the way we are setting at a program level.
What if I have some requirement like I want to get some data from API, and I also want that data to be included with some files. So I want two data, one from the file, one from the API. Then I will process on both of them.
So create, there is one timer, $timer.
Right.
Rename this to timer 1, copy this code and create timer 2 and just tick 1, tick 2.
Okay, you are saying that.
Tick timer 1, timer 2 and tick
Yeah.
yeah. So my understanding is that tick 1, tick 2 both should be displayed every second.
But again, echo is a synchronous function, so it's gonna execute us
That is
synchronously.
fine. That is fine.
Yeah, that's fine. That's fine. But
Yep.
it's executing simultaneously, right?
Yep.
Yeah, that's fine. It's working well.
This is what
Exactly.
you was
Yeah.
asking.
Yes.
Exactly. You don't have to create a loop. Just make sure that you don't create a
Okay.
extra loop.
What if I
Don't just create a
create
loop,
a
but
loop?
you add a multiple.
You can add 10,000 timers.
Okay.
You can add 10.
एक infinite while loop है, उसमें तुमको जो भी run कराते रहना है, उसमें कराते रहना है.
Exactly.
Can have multiple processes. Can be anything.
Can be anything.
Loop एक ही होना चाहिए.
Just make sure.
So we wanted to look at asynchronous thing. So this
Yes.
example is showing the asynchronous.
Asynchronous.
Exactly, right? And that's why my next example was the same thing. So we're gonna go to control timer. I'm just gonna check out the revision. I'm just gonna don't check out. Let me just.
Stack
ये
है.
कौन सा editor है? ये इसको है.
PHP Storm.
ये paid है ना?
Yes.
Student के लिए free है. इससे personal भी free है.
Personal net free, but you get if you are student and if you are open source contributor. So,
But heavy काफी है.
yes. So add periodic timer again.
MacBook पे चला रहा है वो. तो Windows पे चला है वो.
Exactly. So add periodic timer.
Pro ऊपर.
This is just setting. So this is kind of a similar example. I'm adding two timer at the same time. I'm canceling one timer and then stopping the timer, and then I'm stopping the loop also. If I want to, so I just wanted to show that you can actually stop a loop at any point of program execution also. So this will not execute only this add timer of 5 seconds.
What if I want to stop any particular one instead of stopping all the loops?
There is only one loop running. You can only stop one loop. You cannot stop two different loops.
What is the difference
You
between?
can cancel
Tom's timer stop and loop stop is a different thing.
How to stop a timer?
If you stop loop, the timer is already the.
Yeah, previous example we saw that
वो रहा cancel timer.
This is cancel timer.
Okay, sorry. Yeah.
So if I run composer run dev, you see the done is never gonna execute because we stop the loop there. So that way we have a like program execution way wherever we have to stop the loop. If something happens with a connection, goes haywire, we can stop it. So that's one example. Then smart checkout, man.
Wow.
Okay.
Congratulations.
So this is merge what you're doing right now.
Yeah. Okay, now we saw the way to get a loop and everything, but now you directly call the loop also. It's gonna behind the scene, it's gonna give you that same loop. You don't have to get loop get and loop run. So it's just a nice utility kind of a thing. Like you don't have to define that everywhere you have to run it or not. You can just start a loop, tick 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 tick. After 10 seconds, it's gonna automatically cancel timer. Right? So it's kind of a facade, Laravel, which most of guys hate. I don't hate Laravel facades. So that's one way of starting the loop. Now we will see how event loop works when stopping. Now this is kind of one very interesting use case, and I will tell you why. If I stop and start another stop and start the loop, right? What will happen? There is like very crazy thing happen. I'm gonna talk about that also. So I start this for timer 4 seconds. I was running that stop. Sorry, I was running this periodic timer tick tick tick. I added one extra timer where I was canceling the timer. But now what I did was I added a timer in 3 seconds where if a loop is a loop interface, then I just stopping the loop. Once I stop, I go and I run it again. And I told you, right, it's very important to run one single loop. If you stop it and run that again, that's gonna create a problem because that's gonna create another loop. Because once you stop, that entire thing gets created from memory, and that's why you see this. Because the one callback from another loop is actually now coincide with a different loop. So first loop is now have this couple of things pending, which are now actually coming into the another loop which we started here. So that's why it's very important to not to run this. And now if I just remove this, right, it's gonna
Complete this now.
exactly.
Third.
But here you are stopping the first loop itself, and then later on you are starting a.
Yes, so I will tell you three cases. Okay, so now here we are setting a periodic timer. Okay, now this periodic timer, what exactly telling machine that every 1 second I need to execute this callback. Now that is being considered with the whatever the new loop I have started, that's coinciding with that. But the problem is it doesn't know, I don't know this loop variable, so it's just going into that while loop again and again and again and again. That callback is being called again and again and again. That's where exactly the problem is happening. So you have to be also careful when writing this stuff. So if you start and run the same loop again and again, then that's gonna create a problem.
More power, more resources.
Yeah.
Add timer and add periodic timer. दोनों को सेम ये है. पैरामीटर सेम है.
Yeah, it's an interval and callback function. Simple.
For both. For periodic timer.
Yes.
as well as timer.
Yes. It's very same.
What is the
Just a PHP thing.
multiple periodic timer and
Events, signals basically. Okay, signals are nothing but a way to communicate with the programs. Whatever the program you are running, right? That's a way of running a signals. So if I run this, now just what I'm doing is I'm just added one single periodic timer. Whatever is the value, I'm just running how much time it has been run. Okay, and then whenever I'm listening for this signal called SIGINT. SIGINT is nothing but a way to stop Control C. In a simple term, it's stopping signal. Okay, and whenever I get that event, I just execute this listener. It's event driven. Again, you get it. So whenever I get this, what I'm gonna do is I'm gonna handling the interrupt signal, sleeping for 2 seconds, and just 3 seconds. My bad. And then I'm just execute done. So if I start there, sleeping for 2 seconds, done. But you see, we didn't like the execution didn't stop. We have to explicitly tell that now if you want to, because we are now listening that this is kind of a in JavaScript there is a prevent default, right? We are actually changing the behavior of the SIGINT functionality of the loop. Now if I just do one thing, I just do Exactly. Right. Now let's. Yeah, I just stop the process. Very simple way of doing things. I now control C, waiting for 2 seconds. Loop stops. So
You need to explicitly tell it like
because you are preventing default behavior of the, you are changing the default behavior of the loop. So you have to make sure that you are stopping all the things correctly. You are not, because otherwise the memory leaks will started happening, and you have to avoid that.
It is a Linux thing.
It's a PHP thing. It's a PHP constant also. It's nothing but an integer. Whatever. So it's a
It basically convert events to integer values.
no.
We'll come back to
Yeah.
that later. How going on from it.
So now SIGINT is nothing but a signal. Basically, there are when any process you can communicate via signal. So now there is a concept called stream, and I will tell you it's a most important thing whenever you want to work with any IO operation, because everything is at the end of the day is a stream. TCP connection is a stream, UDP connection is a stream, working with file is a stream. You don't get data, like whenever you see, don't get data directly, all the data JSON, right? It chunks into stream, the HTTP protocol chunks into the stream, pass that to the network, and then you get those streams, and then you work with those streams. That's how it works, right? So we're gonna see how exactly the stream works here.
So the question on how many signals we support is control C is a one, right?
There are many,
But
many.
there will be only the command line signals will be there, right? How we can do with HTTP request? So do we have a signals on a HTTP request?
Yes. So when you HTTP is request nothing but a TCP connection. HTTP request is nothing but a TCP connection. TCP connection at the end of the day is a network connection, and network connection is a stream.
And start do some kind of signals.
No, whenever you get a HTTP request, it is, you get a TCP protocol with certain parameters, right? Get this resource, whatever the version protocol, that's a protocol, right? HTTP is a protocol. So whatever the protocol request you get that, and then you pass that protocol. There are RFCs written for that, like how to pass this HTTP protocol, WebSocket protocol.
Sorry, I skipped a bit. At which topic we are?
So we are talking about stream. So now what exactly React PHP does is, stream is a very low level concept, right? Where you have to deal with a lot of streams. So stream, React PHP gives you a package called stream. Okay, you have to install that package, and it give you three kinds of a stream. One is a readable stream, another one is a writable stream, and another one is a bidirectional stream. Okay, so all these network protocols, file accessors, everything they uses the bidirectional stream, and in that also bidirectional stream, the way React PHP intelligently does that is, readable stream is the one part of a bidirectional stream, and the writable stream is the one part of the bidirectional stream. So by mixing both of them, they actually create a duplex stream. So to understand this, right, basic stream is, the way simple stream works is standard input, right? So standard input, I'm just gonna show you this example. Okay, I now started a loop. Behind the scene, when you start this resource stream, the same thing will happen. If you have not started loop manually, the React PHP will figure out and will start a loop for you. So you don't have to worry at the end of the day. So now I see there are multiple events. So you can look at a documentation. There are multiple events which you can listen. Data end, close, everything, like stream close, what happened, how to process that. So whenever I told that whenever I get data from this standard input stream, I want to string to upper, and then whatever the data which I have got, I just need to string to upper. It's just to show you how exactly it works. So see, I word hello. It's just doing string to upper and just giving that response back to the stream, because I'm doing echo. I'm not writing it to the stream. Echo behind the scenes write into the stream and everything, that do all the things based on the whatever mode you are running. If you are running in CLI, it will use standard output. If you are running it as a PHP FM, it will write out the browser PHP, sorry, HTML basically. Yeah, so that's how exactly it works. Now there is a thing called writable resource stream, and it's nothing but a standard output, whatever the standard output you are. So I'm just gonna output rat to hello. So I'm just gonna comment this out. I stop this loop, and this loop will run forever because it's now waiting for data. And whenever we end it, it's just gonna. So it's a stream now. It's gonna behind the scene. It's gonna run event loop and it's gonna run it forever. So now I'm gonna run composer run day. I just started the loop, write the data to the standard output, and at the end of the day, I just end it. So now if I want to show you guys example where we can use both of this React and the readable and the writable resource stream with each other. So now you see I creating a readable resource stream here with a standard input, readable or writable resource stream with a standard output, stream on data. I'm just doing the same thing, but instead of now writing echo, I'm writing it to that standard output. So whenever you are getting the data, you have to process it. Like HTTP request, you get it, you want to process it, and then after processing it, you need to do something on the standard output. At that place, it will not output. It will some event listener of server, right? And I'm also added a periodic timer to show you that's happening in the same loop. Okay. I'm just gonna run it again. So tick is working. Now I'm just adding something. See, I added something and that's being processed over there. And that tick was just added. If I just added printer or 2 seconds, that is not being visible. So now you see the event loop is running behind the scenes. The moment stream come, it execute and again send back the response to the. And whenever I stop, I just stop it. So that's a basic duplex stream. You have a. I'm not sure if I added example for this. I didn't, but there is a very nice thing they give us called pipe. Okay, whatever we did, it's just a way to like tell that from readable to resource. I just need to pipe that output, and I just output. Okay, so right. So whenever I get something on this, I pipe it to the output. That's a just a syntactical sugar for writing this. Get it? Whatever I'm writing, I'm getting that back. Now this I can pipe it to string to upper function, then whatever I want to do it, right? So that's how it works basically. So this was about stream. Now stream is also a very low level thing. Now there are also good things on top of build. Exactly, everything with React uses event loop. Whatever the thing you are using. So let's go to see the string. It's an event driven readable writable stream for non-blocking input IO. So now you can actually do couple of things with the stream also. You can listen, like you can read a file, and whenever you start reading that file, you can get the data into chunks. You can execute something and you can pass it to another stream also. So that's also something you can do. So FTP server and they use these streams behind the scenes. Right, so there are a couple of events you can listen to: close, error, pipe, train, right end. There is a duplex stream which we talked about, right? So duplex stream is nothing but just a minute.
The read and write.
Exactly.
Together.
Exactly. And you see usage wise, basically I show you the example of this, right? You start writing this, you pass it to the TCP connection instead of this resource stream, right? And then your FTP server is basically that only with specific response format. So that's how you can actually behind the scene how these things actually get work. Okay, now let's another thing called a promises. Now promises is a very interesting thing. Now you see it's a very low level thing, event loop and everything. Now you want some, like whenever I want to execute something, I will not start a event loop every single time. I will not deal with it. Exactly. So it gives you a very nice interface to work with the event loop, right? You just tell that I want to execute something asynchronously. Whenever it works, whenever it happens, just give me the response. If some error happens, then also give me whatever happens. Just give me the response back at the end of the day, and that's nothing but a promise. So that promise method is going to tell that I'm not going to give you response right now, but I promise to give you response at some time, right? That's something as a very basic as promise. And there are also many things like you see it's the same as the JavaScript promise, then catch, finally cancel, right? All these are kind of a same in the JavaScript, right? Promise, resolve, reject, same thing you do it promise. Right? If you are working with normal promises in JavaScript, you are actually working with promise, resolve this, reject this, exactly, right? And we are also gonna see the example of the promise then.
Can you do it?
Okay. नहीं नहीं have it I don't ले लो मैं नहीं पीता ही नहीं
तो मैं भी दिया आया है पी लेते हैं
This is the
so the thing is there is this code I have written to show you how the promise works, right? So there is this request which gonna gives you a promise, okay?
Syntax be completely JavaScript.
Exactly.
Same JavaScript.
but that's nice.
Right? So you know some concept of JavaScript. Now you can actually apply that in the PHP, right? You will easily able to write async programming. So now there is this method called default, right? This nothing but a promise only. Like it gives you promise interface at the end of the day. Now what you do is you call async function into this, okay? In that promise, there is one method in that you called async function, and whenever that async function you just pass a callback to it. Like every way in the promise also you pass a callback to it. That promise that takes a error, like basically some error happens or not, and if it's a result, okay? And then you just pass that default. Whenever that execution happens, that callback gets executed, you're gonna reject if there is a error. If there is a not error, you just gonna resolve that. And just you right now you don't execute this function. This function is not gonna get executed, but you are just gonna get a promise here that I'm gonna execute this, and whenever it's gonna happen, I'm just listening on this get awesome result promise that whenever this happens, whatever the resolve value is, I just want to echo it, and if there is also error thrown, I just want to listen to the message of that error. Okay, so we're gonna close this event loop. Okay, I didn't add anything, but what it simply does is it's called that async function. Async function is waiting for 3 seconds and then just calling that callback. That I just need to call back with this value hello, and if there is an error, some error, let's suppose we throw error, throw exception. Okay, now I'm gonna throw this exception which is gonna catch here, but callback is gonna pass shit happens, right? It's if we want to modify, we can just throw the exception on as it is. So wait for 3 seconds, shit happens. We are passing that exception here. Exception is again being passed here to the on rejected function, and where we are listening for the message. So there is a syntactical sugar, like these are the on fulfilled, on rejected. You can directly listen to catch also. On rejected, what will happen? Just a syntactical sugar. You have a flexibility to write the way you want. So you can remove this function
And
put it here.
promises कब डाला था JavaScript में?
ये 6 में.
6 ना? This was before that.
The same thing will happen. 3 seconds, shit happens. Yeah, it's a basic promise concept, so you understand how exactly this works behind the scenes. Okay, now I'm gonna.
So question is like, which came earlier now out of these two? Because I always thought that JavaScript had that.
So it's a very old thing. Like even C, like C++ also has a promise, but they implement it in a different way. Like they okay. Now you see there is a very fundamental problem with the way the code is very bad. You see, it's like very branch code. Then catch. It's very branch code, and you see that's a problem, and that's why the async await come. You can wait for that.
The callback hell.
Exactly, callback hell. right? And that's why async await, and React PHP also has async await. So now we are going to see that async await thing. So check out. Right. So now you see that same function is there. The whatever I'm gonna do, that the same function is there. But instead, whenever I want to listen, I just awaiting passing that to await function. That result is gonna, and I'm just adding try catch on that. The same syntax what you use in JavaScript. It's same. The execution will be also same. The shit happens will be printed after 3 seconds. No, doesn't. I'm not. I'm not echoing. But let's throw error. I also don't know what will happen if I throw error. Yeah, exactly. Right. So you understand it's a just little bit of utility. Now coming to us, you understand how this low level stuff works now. Now whenever you have to work with any ghazal and everything, you can actually think of writing it in an async way. Wherever you are thinking that this is IO intensive, we can actually write this async way.
Ghazal has also function async and sync.
Yes, they have.
They have by default.
Yes, by default means they use the kind of same concept of what React PHP works uses, right? But they don't need an entire functionality of that, so they just extracted whatever functionality they wanted and they use that. Also, if you want to, there is their own React PHP also has their own HTTP layer, so you can actually use this to send GET request and all. Browser.get browser, and it's same as Ghazal, so both RFC, whatever that RFC is, what is it called? I forgot that number. RFC, some PSR 17. Sorry, PSR 17. It's like to send any HTTP request, right? They have to follow that PSR, and that's entire being followed here. So whatever you see, right? You get a very nice utility of getting it here, and whenever that's gonna pass, it's gonna pass a promise. You can async await whatever you want to do. Now I'm going to show you how Laravel works. Laravel, I'm not sure if you know, but Laravel also has some things where code works asyncly. So there is first thing called HTTP client, which is async way. Okay, so HTTP request has a async way. So if I search for async, I don't find anything. But if I search for pull, I also don't find anything. I'm not sure. Oh, this is not a right. Yes. But I search for pull. You see, this is a concurrent request. So now I told you one use case where I will query the post thing. Okay. And now I want to query 10 different post APIs at one time. So now what you can do is you can make them as a part of array. You can get pull get, dynamically set all those variables. You can call that all 10 APIs in one go. You will
Like
promise resolve all. Yes, promise all, and that response will be there, and that array will have the proper Ghazal HTTP response once that entire all the 10 requests completed. So if request is completed or not, you can actually check by request. Okay, request is successful, is the requesting. So that's because of this, you can also name those, by the way, if like post 1, post 2, and by this I'm not sure if you have used this or not, but do you think there is a very good use case for this?